Okay, so today we're going to use this map. Now, if you think of the map, and this is the map that I'm going to say, and we're going to say we start in Bowling Green, right? We're going to go through Findlay. We're following 23 here. We're going to go through Upper Sandusky. We're going to go to Marion, right? That's our map right there. We're going to pretend that's the map. Okay, now, if I asked you this question, answer it out loud. I can hear you. I'm right here. I can hear it. Just yell it out when I say this. Okay, there's our map. Bowling Green, Findlay, Upper Sandusky, Marion. How do you get to Marion? What? Okay, now, for you that said you go to Bowling Green, to Findlay, through Upper Sandusky, then to Marion, well, do you mean that you drive all the way to Bowling Green before you start going to Marion? I hope your answer is no, right? If you're in Upper Sandusky, you start in Upper, you end in Marion, right? That's how a map works. You do not have to start at the beginning of the map every single time. If you wanted to stop in Upper Sandusky, you wouldn't have to go to the end and then go back. Just go right to where you want to go as the map tells you. You don't need the beginning. You don't need the end. You just need to follow the pattern in that order. Hey, school's out. Sorry, guys. See you later. Okay, let's finish this up. Okay. If Chad mixes 3.2 moles, look what it says, 3.2 moles of nitrogen, that's not grams, with sufficient, reacting with sufficient hydrogen. How many, oops, I don't need to highlight that, do I? How many moles of ammonia, there it is, ammonia will be produced? Okay, now, remember how when we went to our balanced equation, or went to our equation, we wrote it above it. Let's write above like I have done in the past. So it says we have 3.2 moles of N. Write 3.2 moles. Remember, MOL is the abbreviation for mole, not little m. You can't use a little m. That's going to be molality later. We don't want to mess up that kind of stuff because it's going to come back and change. And we want to know how many moles of ammonia, MOL, above ammonia, question mark, because that's our unknown. Given moles, unknown moles this time. Let's look at the map. The map has all these grams and mole in the middle. Look what happens. Wait a minute. Oh, I accidentally enlarged it too much. And now the map only shows mole. It's a Christmas miracle. No, it's not a Christmas miracle. It's a stoichiometry miracle. If we're given moles, then we don't need to start with grams. If we're going to go to moles, we don't need to end in grams. We can stop and start where we want on this map, as long as we follow the pattern. You didn't think I'd say pattern so many times, did you, in this class? Well, guess what? Buckle up. All right, so here we go. Starting with moles. Start with, oh my gosh, no one's balanced that equation. Another Christmas miracle. We get the chance to balance an equation. Oh, man. Good things are happening. Good things are happening. All right, let's see what we have here. Well, I'm going to find something different. I see two N's on one side and one N on the other. I'm going to throw a 2 in front of this side and make them even. Now I see 6 H's and I see 6 H's. And I'm done. If you squint your eyes, that little 2 almost looks like a candy cane. Just say it. Christmas miracle. Okay, here we go. Starting with our given 3.2 moles of N2. What are we trying to find? Moles of NH3. What are we trying to cross out? moles of N2. I hope, oops, Mr. Arnold, you're in the way. Hey, that's a good spot. All right, so moles of N2, right? We're crossing out mole. We don't have any grams if we're going mole. No need to look anything up. No need to get out the table, right? We don't need you, right? So we don't have to worry about that. All we have to worry about that mole ratio. So let's look at the equation for that mole ratio. We have 1 N2, and I'm getting that right here for you folks who are not sure where I'm getting that. And we have 2 ammonias. Boop. Wait a minute. Dun, 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 dun. There you go. So we have 2 ammonias. Now, that should be an easy math. I can't really write with white. It doesn't show up very well. So what do we have? Oh my gosh, I've got 6.4. I didn't even use my calculator. 6.4 moles of NH3. All right. That is the gist. I hope that is enough. Look what we got here. I'm going to highlight. I can't stop. You know that. How many moles of KCl? How many grams of KClO3? Okay? So, again, we're starting with moles. We're ending in gram. I can't help it. I've got a problem. I'm too helpful. All right? See what you're doing now? Go through that same thing. I'm going to do the next part to start us off. Da-da-da. Nitric acid is HNO3. And let's see what we have here. Ammonia is NH3. Unbalanced equation. Okay, and that's already listed, and that's listed. How many moles, we don't even need to tell you that, do we? How many moles of no, that doesn't sound very festive, react with this many grams of NH3? So this time who would have thought that I would do mole to mole to gram, and then do a gram to mole to, or I'm sorry, gram to mole, and we don't need the grams at the end, right? So I got a problem. I know, I see it now. Moles, question mark, grams. Oops. Yeah, moles, question mark, grams of NH3. Okay. So I hope that helps. The last one, they gave you all of it, so that's all the way through. Hey, good luck with the balancing. I thought that'd be fun. I know you guys love to balance equations, and I thought that'd be a good way to end things on that. So this is a nice little stoichiometry variation for us, and finish it off with a gram to mole to gram. So good luck with that. I got to stop talking because I know you're tired of hearing me talk. All right, let's do it. Let's shut her down.